We're going to finish up Unit 1 today. We're going to look at the learning targets of adding and subtracting matrices. Matrices would be more than one matrix, and also how to multiply a matrix, a singular one, by a scalar. A matrix. When we talk about a matrix, it is an arrangement of numbers. And we call these numbers elements. So elements are numbers in the matrices, and they're arranged in rows and columns. Okay, rows being across, columns being up and down. The order of a matrix, we say, is the number of rows by number of columns. So it's always going to have two numbers attached to it when you talk about the order, how many rows and how many columns the matrix has. All right, so below is an example here of a matrix. Okay, these little bar things you see around here indicate that we have a matrix. It's kind of like a table of numbers. Those numbers are called elements in there, and they represent some type of data. All right, so for this one, we would say that these different rows in here, those would be row 1, row 2, row 3, and then we have 1 column, 2 columns, 3 columns, 4 columns. So each row and column would be indicated. So when we're trying to say which element is located in row 3, column 1, you'd follow row 3 over to wherever you want to go. We'd follow column 1 down. And it looks like 3 is the element located there. Same with this next one, which one's in row 1, column 4. If we follow this over to column 4, it looks like 2 is the element in there. If we wanted to describe the order of this matrix, since we have 3 rows, we would say it's a 3 by, and we got 4 columns, so a 3 by 4 matrix. That's the order of this matrix. All right, how to add and subtract matrices. To be able to add and subtract matrices, they both have to have the same size, meaning both must have the same order, same number of rows, same number of columns. If they don't, then you cannot add or subtract those matrices together. In this example 2, if we wanted to find the sum or add these two matrices, you want to add the same element in the same location together to get the equivalent matrix. So this one, the answer is going to also be a 2 by 2 matrix. We want to add the same ones together. So we're going to add 2 and 6 together. We get 8. We want to add these 2 elements together because they're both in the same location. 5 plus 3 is also 8. We want to add 1 and 2 together because they're in the same location, which would be 3. And then finally add the last 2 numbers together. We get 5. So that would be the answer on this one. Okay, let's try subtraction 1. Example 3 here, we want to subtract these 2 matrices. We can subtract it because both of these are 3 by 2 matrices. They both have 3 rows and 2 columns. So yes, we can subtract it. So now you do the same thing. Subtract each element located in the same location, and we should end up with a 3 by 2 matrix. So if we subtract 9 minus 6, we get 3. If we keep going and doing similar thing here, 2 minus 3 is going to give us a negative 1. And then you keep going. If we do negative 3 minus 2, be careful when you're subtracting a number from a negative. It should be even more negative. That's going to turn out to be negative 5. And then we keep going. 0 minus 4 is going to be negative 4. 5 minus 7 is going to be negative 2. And finally, 1 minus negative 3. Again, be careful. 1 minus a negative 3. If you're subtracting a negative, Some of you like doing like the double slash thing or whatever, making that into a positive. We're really adding there, so that ends up being 4. So that would be the answer on this one. All right, if you look at the back of your note sheet, if we want to do some multiplying, oftentimes they associate a matrix with some kind of letter. So they might say, this matrix right here is matrix A, and it's a 2 by 2 matrix with 4 elements in there. Well, what if we wanted to add A, that same matrix with itself? If we added matrix A with another matrix A, remember we just talked about adding, we get 3 plus 3 is 6, negative 2 plus negative 2 is negative 4, etc. We get this as our answer. Well, if you add A plus A, that would be the same as 2A. And what's the same as finding 2A without adding? It would be multiplying, same as multiplying each element by the scalar number of 2. So if we just multiply each element in this matrix by 2, you would get the answer, same answer as we got over here. 3 times 2 is 6, 2 times negative 2 is negative 4, 4 times 2 is 8, and 7 times 2 is 14. So multiple adding or multiple subtracting is the same as multiplying a matrix by a scalar. Let's try some multiplication here. So on this one, we have this matrix A. As you can see, it's a 3-row by 4-column matrix. And what they want us to do here, this is matrix A, they want us to find 3A, which means we want to multiply each element by the scalar number of 3. So matrix 3A here would equal matrix with the same order. We just need to multiply everything by 3. So if we start here with 2, 2 times 3 is 6, 3 times 3 is 9, negative 1 times 3 is negative 3, 6 times 3 is 18. If you keep going here, you get 24, 15. Now 0, remember 0 times anything is still 0, so that number stays the same. Oops, sorry, negative. If we multiply negative 2 by 3, we're going to get negative 6. And finally, the last one, the last row, we'd have 3, 12, 21, and 27. So now this would be the answer by multiplying that by a scalar of 3. All right, let's try just some more practice ones with adding, subtracting, multiplying. If you look here, each matrix has a letter associated with it. Okay, looks like some of these are 1 by 3 matrices, B and F being 1 by 3 matrices, and we got a couple 3 by 3 matrices as well. So the first one, problem 1 wants us to add D plus E, so we got to check. Can we add D plus E together? They got to be the same size. Yeah, so it looks like these are both 3 by 3 matrices. We should be able to add them together. Why don't you pause the video quick, see if you can add these together and see what you get. All right, let's check, see how you did here. If you added these correctly, you should have gotten the matrix 2, 7, 8, 5, negative 1, 8, and 9, 9, negative 7. Again, adding each element in the same location. All right, number 2. They want us to now find what's 2 times matrix CB plus F. So just like order of operations we talked about before, you got to do multiplying first and then add together. So the first thing here, let's see what matrix C2B is going to equal here. So if we take this matrix right here and multiply each element by 2, we get 6, 30, and negative 16. Now they want us to add that with F. Well, let's check. Can we add these two matrices together? Yes, they're both 1 by 3 matrices. So we should be able to add that together. So the matrix of 2b plus F, then adding these two up would be 18. 30 plus negative 4 is 26. And negative 16 plus 16 would equal 0. So that would be the result that you get. All right, subtraction. If you're subtracting, we looked at subtracting as well here. F minus B, they want us to take this one minus this one. Just notice the order here. Okay, order is important when you're subtracting. So if we're going to subtract these two, we got to start with the element in F, which is 12, and minus the element, same element in the same location there, which would be 3. 12 minus 3 would equal 9. Doing the same thing here, negative 4 minus 15 would be negative 19. And 16 minus negative 8, again, be careful. Minus a negative, same as adding, that should end up being 24. So that would be the answer there. Why don't you pause the video, try this very last one on your note sheet. It does involve some multiplication, so make sure you do the multiplying and see what you get. All right, let's check it out. On this one, first you'd want to multiply everything in matrix E by 3. Okay, giving you this matrix, or sorry, negative 3, giving you this matrix. So if you multiply everything by negative 3, you get negative 3, negative 3, negative 3, 12, 12, negative 9, negative 9, and negative 6 is negative 6. Then what they want you to do is take this matrix and minus this matrix, and the answer then, if you did it correctly, should also be a 3 by 3. We're subtracting two matrices of same order. This should have been the answer that you came up with if you did it correctly. So matrices, nothing hard. It's just some adding, subtracting. You just got to keep track of the location, make sure they're the same size. All right, try some of the ones on your practice worksheet.